Today we're talking about operations with radical expressions. So, like radicals have the same radicand. For example, 4 square root of 7 and negative 12 square root of 7. They have the same radicand. That means they have the same number under the radical sign. Unlike radicals do not have the same radicand. For example, 3 square root of 11 and 2 square root of 5. The number under the radical sign is not the same, so they're unlike radicals. If we have to simplify, the square root of 2 plus 3 times the square root of 2, we can see that these are like radicals. They both have the same radicand, the number 2. So this means that we can use the distributive property and say 1 plus 3 times the square root of 2. Means we're adding the 1 that's being multiplied times the square root of 2 here, and the 3. This would equal 4 square root of 2. If we need to simplify, negative 3 times the square root of 5 minus 4 times the square root of 5. Do we have like radicals? Yes. So that means we have to look at negative 3, negative 4. What would this equal? Negative 7 square root of 5. Simplify 7 times the square root of 3 minus the square root of 12. Do we have like radicals? No. Because we do not have like radicals, we need to simplify to see if we can make these like radicals. So can we simplify 7 square root of 3? Can we simplify the square root of 12? We could say the square root of 4 times the square root of 3. So the square root of 12 simplifies to 2 square root of 3. So now our problem would be 7 square root of 3 minus 2 square root of 3. Are these like radicals? Now that they're like radicals, what do we do? Subtract. So 7 minus 2, 5 square root of 3. Simplify 3 square root of 20 plus 2 square root of 5. Which of these problems can I simplify to see if I could get it to have like radicals? 20. So we already have our 3 here. I'm going to circle it so that I don't forget about it. Say square root of 4 times the square root of 5. Square root of 4 is 2. 3 times 2 is 6. Square root of 5. And I bring down my plus 2 square root of 5. Are these like radicals? Yes. So we can add 6 plus 2, 8 square root of 5. So to simplify, the square root of 3 times the square root of 6 plus 7, we have to use a distributive property. So we're going to distribute the square root of 3. The square root of 3 times the square root of 6 plus the square root of 3 times 7. 3 times 6 equals the square root of 18 plus 7 times the square root of 3. Are these like radicals? No. So what do we have to do? Simplify the square root of 18. So we can say the square root of 18 is equal to the square root of 2 times the square root of 9. Root of 2, square root of 9 simplifies to 3. Got 3 square root of 2 plus 7 square root of 3. Can I simplify any further? They're not like terms. That means that I leave my answer as is. Okay, if we have to simplify two radical expressions with two terms each, we can use the FOIL method. So we would say the square root of 5 times the square root of 5 plus the square root of 5 times the square root of 15, then plus negative 2 square root of 15 times square root of 5 plus negative 2 square root of 15 times square root of 15. So you can say the square root of 5 times the square root of 5 is the square root of 25. The square root of 5 times the square root of 15 is the square root of 75. Negative 2 times the square root of 75. Negative 2 times the square root of 225. So now we need to simplify each of these square roots. The square root of 25 is 5. Can we simplify the square root of 75? Okay, we would say the square root of 25 times the square root of 3. That means 5 square root of 3. This means 5 square root of 3 times negative 2, which simplifies to negative 10 square root of 3. Can we simplify the square root of 225? So that means 15 times negative 2, negative 30. We can now combine like terms, so we can say 5, negative 30, we can say negative 25, and we can combine 5 square root of 3 minus 10 square root of 3, which would be minus 5 square root of 3. Conjugates are the sum and the difference of the same two terms. For example, the square root of 5 plus the square root of 2 and the square root of 5 minus the square root of 2 are conjugates. The product of two conjugates results in the difference of two squares. For example, the product of the square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2 would equal to 3. Notice that the product has no radical. So we have to simplify 6 over the square root of 5 minus the square root of 2. We have to rationalize the denominator using conjugates. That means we have to multiply times its conjugate. Square root of 5 plus the square root of 2. And you have to do that to both numerator and denominator. That would equal 6 square root of 5 plus 6 square root of 2 over 5 minus 2. So this means the same thing as saying 6 times the square root of 5 plus the square root of 2, right? Over 3. Do the numerators mean the same thing? Yes, right? Now, why did I go back to using these parentheses? Well, because it's easier to see that you can simplify this and then say 2 times the square root of 5 plus the square root of 2 over 1. This means 2 square root of 5 plus 2 square root of 2.